We are going to work on permutations and combinations this week. Permutations are counting the number of ways that an event can happen, and so are combinations. However, there is a difference between the two of them. The difference being that permutations, the order matters. Permutation is like a password. So if you can think they both start with P, permutation and password, the order matters. Combinations, the order doesn't matter. It's like a combo meal. It doesn't matter the order that you ordered it in, you're still going to get the same food. So combination and combo meal. It doesn't matter the order, you're still going to have the exact same amount of food on the tray as somebody else, even if you ordered the Coke first and they ordered the hamburger first, you'd still both have a Coke and a hamburger. But permutations, the order matters. If you don't enter your password in the correct order, you're not going to be able to get into whatever you had the password for. There are formulas for each of these that we could use to calculate for permutations and combinations, but we are going to use our calculator to calculate them. So permutations, order matters. Here is how we are going to use Desmos. You will open Desmos on your iPad. You will go to functions. Then on the functions, you're going to go to statistics, and then you'll either be able to select NPR or NCR. And P stands for permutations and C stands for combinations. When you put in the two numbers that we're going to use, you have to separate them with a comma, and then your answer will be coming up. So let's start with practicing permutations on our iPad. So again, you're going to go to Desmos, go to functions, and then statistics. You're going to select NPR, and then you're going to put in your two numbers, 11, 8. And what this stands for means I have 11 choices and I'm going to pick 8. So after you've separated those with a comma, you will find out that your answer is quite large, 6,652,800 different ways that you would be able to select. On permutations, when we have 24, pick 5. Use your Desmos, select functions, and then go to statistics. You're going to select NPR. Make sure you put it in as 24, 5. And then you should see an answer of 5,100,480. How will we use this now in a situation? There are 15 people on a baseball team. Since order they hit in matters, so order matters, we're going to use a permutation. And we have 15 people, and we are going to pick 9 for our batting order. So on your calculator, go to Desmos, go to function, then statistics, select NPR, and we're going to put 15, 9, and you're going to be amazed that there are 1,816,214,400. I think I said that wrong. 1,816,214,400. We now are going to do a problem that's talking about a password. So when we're doing password, order matters, we are going to use the digits 0 through 9, which means there are 10 digits, and we're going to pick 4 of them. So on your iPad, we're going to do exactly the same thing. Go to Desmos, go to functions, then statistics, select NPR, and you're going to put your numbers in separated by a comma, 10, 4, and there will be 5,040 different passwords. All right. Now we're going to work with combinations where order doesn't matter. So this is like a combo meal. Exactly the same thing. We're going to use Desmos. Go to Functions, Statistics, but this time you're going to select NCR. And again, we have to separate these by a comma. So this is 11, pick 8. Now you knew that when we did permutations it was huge, but now since order doesn't matter, you're only going to get 165 different ways. Same thing with 24, pick 5. We had a huge number with permutations, but because order doesn't matter, this time will be 42,504. So using this in a practical application, you're playing kickball. You get to pick 6 out of 12 people. But when you do that on a team, it doesn't really matter the order that you pick the people. It doesn't matter about our kicking order or anything. So we have 12 and we're going to pick 6. Order doesn't matter. So on your iPad, go to your Desmos, and when you pick combinations, remember to separate those by a comma. You get 924 ways. Ice cream. I want 3 scoops out of 11. I'm going to have 11 choices and I'm going to pick 3. But again, order doesn't matter. So you're going to put 11,3 into your iPad, and there would be 165 different ways that you could make that ice cream cone. Remember, permutation order matters. Here's an example with the word bat and using those letters. You could make 6 different combinations if the order mattered. If order doesn't matter, there's only one, B-A-T, because I have 3 letters. It's like a combo meal. So permutation order matters. Combination order doesn't matter. So let's take a look at 2 problems and see if we can decide which is which. 6 people are running a race. First, second, and third place get a trophy. How many ways can first, second, and third be awarded? Well, hopefully you knew that permutation is what to circle because the order matters. If you get first, if you get second, or if you get third. So there are 6 people in the race. We want the first 3 runners, first place, second place, and third place. So there are 120 ways to award first, second, and third place trophies. You are taking a history test. You need to respond to 2 essay questions from a list of 6. In how many ways can you complete the exam? Well, hopefully you remember that a combination would be for this because the order doesn't matter. Because I can skip down and do question 5, and then I could come back and do question 2, and as long as I've done those 2 questions, it doesn't matter the order that I responded in. So this is a combination of 6 questions, and I'm going to pick 2 of them. There's 15 different ways that I could answer those questions. So permutation order matters. It's like a password. Combination order doesn't matter. It's like a combo meal.